Yeah, so good morning to every one of you people. Today, I'm going to talk about the thresholding concepts and also what is thresholding. So, see, thresholding is nothing but filtering the data once again. So, see, actually, I got the columns, 4 columns. I reduced to 2 columns. That is a future selection. But thresholding in the sense, hey, I don't want the value which is lesser than 60 marks or 80 marks. So filtering the data, not filtering the column, filtering the data can be achieved with the great concept called thresholding. Okay, so we are going to talk about thresholding concepts, and from there we'll proceed with our model selection. Anyway, this is the one. Like this is the one. Like I got my iris data. We got the data, and we got 4 futures. And this is reduced into 2 futures. That is called a linear discriminant analysis. That is called LDA. So the data on applying on the algorithm will be getting these futures. Okay, the 4 futures are transformed into 2 futures. Okay, so over here, if we talk about thresholding concepts or scalar concepts, what is a scalar? Scalar concepts is nothing but transforming the data into a standard format that is called as scalar or standard scalar. So scalar format. Okay, so we got our iris data, we got 4 futures, it is converted into 2 futures, but we are transforming to a standard scalar value. So that is one area in the field of machine learning or data science. Yes. Now I'm trying to tell you how this standard scalar will work. Over here, I got the data. We got 4 futures in it. And this is converted into 2 futures. And before that, I'm trying to convert into a scalar value. So why we need this scalar value, sir? The reason is very simple. Things like I got the data 80, 90, 92, 94, 96, 98. We got enormous amount of different data. In that case, sir, I consolidated, but I need to make it in a scaling value of 0 to 1, converting into a standard value. That is where your standard scalar comes into the picture. Okay, over here, I got this is the library. We got sklearn import data sets. Before going ahead, the person who talked to me now, madam, can you tell your name, please? Are you there? Hello, Manoj sir?
Yeah, yes, sir.
Yeah. Someone spoke in the mid, right? So I want to know, I'm a bit curious to know who is the person talk to me now.
Sir, I'm Dr. Revati, professor from CSC Department, Crescent University, sir.
Okay, madam. Now, just wondering, I want to know who is the person. Okay, yeah. Anyway. You could have wait for another 1 minute, madam, so that I could have finished my session and finish my introduction. Okay, anyway.
Oh, okay, sir. We got all participants are coming from throughout in India.
Yeah.
That's what I
try to understand. Already, I trained almost 5,000 faculties, madam. We know the pulse of everything, madam. Don't worry, madam. We'll take care. And this is
okay,
my almost. I finished almost 40 FDP sessions, madam. In this lockdown itself, this is my 4th session I'm conducting.
Continue, sir. Yeah. Continue.
Yeah. So over here, I got the libraries. This is the library. So this is my main library, sklearn, which will have the sub-library data sets. Over here, for pre-processing, we got the standard scalar libraries. And discriminant analysis, LDA or linear discriminant analysis, it is nothing but like the LDA concept. So reducing the future. See, actually, I got the data. I got the LDA algorithm. So both the things are there. Before applying the LDA algorithm, I'm trying to have my scalar value conversion. Okay, so I got the data, convert it to scalar values, and apply the algorithm. Okay, so like in the last my second session is on LDA, you know it. Okay, it's very simple. I made the entire code. You will have all the libraries, all the codes and everything, over here. The first line is same, the third line is same. You got the iris data sets, and we got the same code. Everything is same. I've added only 2 lines additional code, the second line and over here this line. These things I had given. Okay, so like see, thing is like I want to reduce the future. Before reducing the future, I want to go ahead converting this particular data into a standard scalar value. Okay, standard scalar value. Okay, so obviously for maintaining the standard scalar value, we need to manipulate it. So this is the one line I'm going to type with standard scalar of fitting and transforming the data. Yes. So you may ask me, sir, for this one, like whether any changes of values will be happening? No, because it is a very standard data set, so it doesn't have impact on this particular data set. But if you get any other external data sets, you can see some impact. Now I got my imports library here. Yeah, I'm trying to add like already we have seen the code with the data sets and everything, importing from iris data sets. Now I'm trying to include the standard scalar value from sklearn.preprocessing import standard scalar. Now as we know that we got the LDA here. So now I'm transforming my x value iris dot data. So already I got that one. So which is your x value. I'm trying to convert that data into a standard scalar value. So standard scalar dot fit transform iris data. So that is the one I'm trying to do it. So standard scalar function needs to be applied. So it needs to be applied on the data, fit it and transform it. Okay, fit it and transform it. Yes. Now I got the data like that x data, which is converted to the standard scalar value. Now I'm going to apply the LDA concept now. What is LDA? Converting or reducing the number of futures is called as LDA. So linear discriminant analysis of n underscore components. How many components do you want? So I want 2 components. Okay, 2 components. Now I got my x underscore LDA, which is LDA dot. Yes, I'm trying to fit it and transform it. Yes. Okay, so once I'm telling you, I got the data, I got the algorithm. In the mid, I got my standard scalar value to be applied. Standard scalar value to be applied. Okay, so that is how your LDA will work. Yes, it's a very big piece of code. Okay, you can see the data which is in the normal application is applied, and the scalar value applied LDA. Your normal LDA and your scalar value applied LDA, you don't have any major differences. You don't have any major differences. Okay, the reason is like this is a standard data set. That is the reason. Yes, I'm trying to put in an Excel sheet to show you like the differences. Is there any differences available? Yeah, comparing the previous LDA which I have done, and this is the recent LDA data. So I'm trying to compare the data, looks the same. It looks the same. Yes, this is how you are able to like apply the scalar values. Now let's talk about the threshold technique, future selection using threshold technique. I got the 4 futures here, and from there I'm applying a threshold value. Hey, you have to satisfy this particular data to get your 2 futures. The same concept with a certain cutoff, I'm trying to do it. So I got the iris data, and you got a variance threshold. So like this over here, we are able to filter the data. Okay, this is how you are able to filter a specific value. Hey, you have to satisfy this content, this value to enter into the research. And here is a formulation for simple variance, a bit of mathematics. You know it. So yesterday itself I talked about the variance to you people. Anyway, like this is the actual formulation. So you got 43751, adding it, summing it, divided by 5, you got the value as 4. The individual value 4 minus 4, the individual value, so it's your mean, so like the individual value is 43751 minus the actual value. We'll be getting some values and making it square. The square is here, and you'll be having the number as 5 minus 1, n minus 1, you got 4 is equal to 5, and the like a root of this value, which is nothing but your standard deviation. Okay, so your standard deviation. Okay, this is how it will be. Now let's move on to the technical area. So here is the code. So over here, the same input data sets are there, and you got your input variance threshold, and you got the future selection. And here is your iris data set available. Variance threshold is there with the threshold value. So you got the algorithm. You got the data, you got the algorithm, fit it and transform it. Simple. Let's finish it. And you got the threshold of 0.3. Okay, so the variance value, calculating this value, or calculating this particular column, it should have the variance threshold of 0.3. If it is beyond 0.3, yes, go ahead, or else don't do it. I got the threshold.fit underscore transform of iris data threshold values given. And iris data, you will have the iris data here, and the threshold value is specified here. You are able to see 4 columns become 3 columns here. Okay, now let's talk about the variance threshold. Yes, over here we need to change it. Yes, over here, like this is a library, I'm trying to add it. So sklearn dot future selection, I'm trying to import the variance threshold library. So there is a warning, it's shown, but it's still like a V is caps and T is caps. Yes. So this is the library. So we got a library variance underscore threshold, which is deprecated in the recent version. So I'm trying to load the iris dataset. So you got a variance threshold with a threshold value of 0.2. Now I'm trying to have like, so see, I got the data, I got the algorithm ready. Now I'm trying to fit it and transform it. I got the X underscore threshold. As you people know, you got 4 different data: petal length, petal width, sepal length, sepal width. So you got 4 different data. Now on applying the threshold, you got only 3 data. Now I'm trying to change the threshold value to 0.5, and still I got 3 columns satisfy this particular condition. That's good, man. That's good. So 2, I keep 2. Only 1 column is satisfying the content. Okay. So I'm giving the threshold value as 1. Only 1 column is satisfying the content. This is also the way of like identifying, reducing the number of features. Okay. So like yeah, 0.3, I got 3 columns. So this is how you are able to filter the column. Only if the data, the entire data satisfy a particular condition, only if the data satisfy the condition, you can filter the data. That is how your thresholding will work. Now let's talk about the model selection. So before talking about model selection, we need to talk about sklearn. So sklearn, scikit-learn, okay, you got data processing. Scikit-learn is used for purely for data processing. Okay, and apart from that, it got a lot of other features also, but the major thing is data processing. So as you know, we got classification, clustering, model selection. So these areas are there. Like just wondering, like is there anyone to tell me like clustering? I've told you, right? So I told you about supervised and unsupervised learning. Clustering is supervised or unsupervised? Is there anyone to tell me, please? Can you unmute and tell me? Guys, are you there? Anyone?
Yes, sir. Yes, sir.
Yes. Any one of the attendees, can you tell me? Like, it's not Manoj sir. Manoj sir, don't tell. Okay, the rest of the people. Any one of the attendees. Can you tell me like clustering in which, what is the algorithm? What kind of algorithm is clustering?
So they have posted in chat, sir,
Oh,
unsupervised.
okay. That's good. Oh, like they didn't, I'll check it out. That's awesome. So like Sonal Vembarasan, there is someone like with an ID. Okay, so clustering is unsupervised. Can you tell me like why it is unsupervised? Can you tell me like why it is unsupervised? That's awesome. Sonal have told like the class label or not there. That's awesome. So this is the area we are going to see it now. Okay, maybe like I can tell you in another perspective. The model is not created. We don't have the model. Model is not created. Okay, what is this model, sir? See, like before creating an algorithm and applying it, we need to segregate the data. We need to segregate the data. This segregation of data is not done, like a filtering the data, like a training data and a testing data. This is very, very important in the field of robotics and artificial intelligence. The reason, the reason is because I got my robot ready. It's not that because my robots are used in eye surgery and all. So if it is an eye surgery or any other complex functionalities and complex things are happening, in that case, I don't want my robot to be like doing a malfunction. It should not do a malfunction. In that case, to avoid such kind of malfunctioning, we need a better robot. A better robot. Okay, so for that we need to test the robot whether it is good or not. That is where the artificial intelligence comes to the picture. Over here we got your supervised learning. Okay, supervised learning. So in this supervised learning, we are trying to have a clear functionality of training the data sets and testing the data sets. Yes, let's move on. Sure, you got your data pattern and processing, which got classification, which is your supervised. Now I am going to talk about this classification concepts. So before applying the classification, we need this model selection. We need this model selection. And that is a great functionality called a train and testing functionality. You may ask me, what is this training and testing functionality? Training and testing is nothing but it is like considering I got a huge data sets of 1 lakh data. 1 lakh data. In that case, I want among that 1 lakh data, I got my 30,000 data, 30,000 data. Oh, not 30,000 data, maybe like 80,000 data for training your system. Okay, and for 20,000 data, it can be used for testing the system. Okay, so training and testing is very, very important. How much a percentage you are giving for training and how much percentage is for testing. Okay, anyway, so here training and testing, the data sets are available. Functionality, you got the X and Y value. You can specify the training size and the testing size, and how much, what is the random data you can put it. I got some 10 data, training, testing, training, testing, training, testing. You can have like that. Okay, that's how your functionality is. Over here you got your X value, which got the training data, and the same X value with the testing data. You got the Y value with the training data, and you got the Y value with the testing data. And this is called your training data sets, and this is your validation data sets. So you know it. So this is your training data, your sepal length, sepal width, petal length, petal width. You got the validation data sets, that is your species. Okay, so this is your future selection, and this is your target data sets. Okay, the naming is future, this one is target. Yes, here is the one. So I'm trying to show a sample data set to be created. Okay, I got my sklearn data sets, and I got my numpy as np. So model selection, I got the library of train, test, split functionality. And wherever you got your model selection, you got model selection. So instead of calling me Venkatesam Prabhu Chaikantam, you go, oh, no more advertisement. The madam will get irritated. You'll have Crescent University. Instead of having Crescent University, you can have Crescent here. Okay, over here, list of range of 15, 0 to 14, you got the list. And you got print of X. I got my Y value like X into X. So squaring of the x value is your y. Over here 0, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. You got the values in the squaring values. You got the x and y values, which is applied. The x and y value is applied on the train test split functionality. I want the training data set of 0.65 and the testing data set of 0.35 with the random stage. So this random state is nothing but how much you are splitting the data sets. That is your random data sets. You got the x value, you got the y value. Now I got my ex train. You are able to see it here. I got my 0 train, 1 train, 2 train, 3 train, 4 sorry, 2 test, 3 test, 4 train, 5 test, 6 train, 7 train, 8 train, 9 train, 10 test, 11 train, 12 test, 13 test, 14 train. This is how you are able to get the data. And for testing, I got the same segregations happening here. So here is how the functionalities moves on. This is the one. See, actually, if any people, if you people are researchers, you know, you know how much the data segregation will be. Yes, you can see it here. The training data, you can have the data is coming up here, and you can see the testing data here. Yes, the training data is moving up. Yes, 11 is coming up. And over here, I got my 12. Yes. And here is a X data set. And here is my Y data set available. This is how the data sets are moved. Yes, the data is moving up. So these much functionalities are done by a single line of code. Yes, looks good. This is how the data sets are splitted. And let's move on to the functionality, how it works. Yes, we got our test and train data sets. For splitting, now I got my x value. X is equal to list of range of 0, 15. So now I got my y value, x into x for So like it is kind of an inline statement I'm trying to do it. So I made as X value. Yes. So taking each and every data and making it, squaring it, I'm trying to do it. I'm trying to like generate my Y value, maybe a bracket, maybe sorry, but it should be a box bracket, I guess. It should be, because it is an array. It is an array. Yes, I got the squares of the values. I got X train and X test. We got the Y train and Y test. Yes. Yes, I need to import the libraries from sklearn dot model selection. I'm trying to import the test train split functionality. It's a train because the training is done and testing is done. So like I made a mistake. Yes, a train test split functionality. Yes, I'm trying to give this functionality with X comma Y. We need to give the training size and the testing size. I got the training size as 0.7 and the testing size is 0.3 because the whole value is 1.0. I'm trying to give a random status 0.1, but 0.1 is not a numerical value. You should give a numerical value. So I'm trying to change it now. I'm trying to give 0.5. Let me check it out. It is working or not. Oh, it is not also a seed value. So it's greater than 1. It should be 1 or greater than 1. Yes, looks good, man. Okay, it's working fine. Yes, I got my random status too. I gave my X underscore train. You can see the training value 3, 1, 10, 7, 12, everything. Y underscore train, you'll have the data, and you got a X underscore test, and you got a Y underscore train. 1, 0, 1, 2, 3, it's 4, it's 5, it's 6, it's 7, it's 8, it's 9, it's 10, 11, 12, 13, 14. Yes. Oh, indentation error is there. The reason is like I move to the next line, right? Yes, I need to change this one. Yes, the training and testing data sets. The data is changed. Can you see it? Can you see it? Just note that training data sets, everything is getting changed. Everything is getting changed. This is how the random state will like a shuffle the value, how much you want the shuffling. So it's Y underscore train, or like I should have Y underscore tests. It's a variable. You can have any name, no problem. You can have any name, Y underscore tests. Yes. This is how your training and the testing data sets will be. Okay. Once again, I'm telling you, for making your supervised learning, you need a clear segregation of training the data and testing the data. For training that you got a huge data set, you will be having a training and testing data sets. Yes. So like for like considering a robot is there. A robot is there, whether the robot should move to the left or the robot should move to the right. It should move to the front or it should move to the back. In that case, like I need to like it's not that only the 4 direction. It can be like a north, south, east, west, or northeast, north, south, or north, something like that. It will have the combination. You can have the combination. Northeast, northwest, southeast, southwest. You can have any combination. Okay, you should have all the combinations available. And I got now 8 directions instead of 4 directions. I got 8 directions. Among that, I got 7 direction. Train the robot. Hey, if a ball is hitting you from the north direction, you should react like this. If the ball is hitting in the south direction, you have to react like this. East direction, react like this. West direction, react like this. Northeast, northwest, southeast. Yes, how it should react. You just train the robot. Now, northwest is a direction which I didn't train. Now I'll try to push the ball from northwest direction, because all 7 direction I will like train the robot, and 1 direction I didn't train the robot. So now it's time for me to train the robot. Okay, so I need to train the robot. In that case, while training it, I'm able to identify whether my robot got the artificial intelligence to react somehow. Note this point, somehow. Note this point, somehow. Okay, so for that we need this testing and training data sets. Now I got the sklearn, you got the load iris data sets, we got the targets, and we got the data. Now from there, I'm trying to apply this training and testing splitting functionality. So till now, I created a general data. I told you like how this training and testing functionality works. Now let's move on to the inbuilt data sets. Over here, like I got my x underscore train and x underscore test. The same thing here, I got my y underscore train and y underscore test. So over here, this is how the segregation will be. So I don't want this standard scalar value, just forget it, because now I'm not going to use this one now. Okay, in this particular program, we don't want the second line of code. I got from sklearn input data sets. I got the model selection. I got the train and test split functionality here. You got the data sets, load iris. So the data is taken and the target is taken. You got the training and testing of x and y value. Okay, and here is the method train test split functionality with the x value, y value, and test size is 0.1. Sorry, 0.1. Hey, I'm a bit confused, people. That is Dr. Manisha. The presentation is not seen, madam. Oh, okay. Now it's seen. Okay. My question is very simple to you people. My question is, I got my test size as 0.1. I'm a bit confused. Is there anyone to tell me like how can I split the data? What could be the training size of mine? So Nand Kumar, Nand Kumar Mishra have given an answer. He have given an answer. 0.8 is the answer you have given to me. Any other answers? Come on. Hey guys, we got almost how many of you people are there? We got almost 120 people. I need 120 responses. Come on. Training set needs to be 80% and remaining 20% of tests. Maybe. This is given by Nand Kumar. Come on, guys. At least I want some 10 or 20 responses. Come on. This is the test I'm giving to you people. Instead of giving at the end of the session, I want to give it now. Can you guys, can you like type the message in the chat window? Like I got a training size of, I put it as 0.1. 0.1. Okay. So is it, my first question, is it a test, like is it a valid testing one? The second point is like, if the training size is 0.1, the testing size is 0.1, what could be the training size? So I've asked two answers to you, two questions to you. I don't want to like ask the question at the end of the session. I'm asking you now. Please, I want you people to type it, please. So Rajesh have responded. Raghu have responded. That's good. Raghu have responded. Hey guys, only 3 people have responded. Come on, I need at least 20 responses. You people should like almost 124 people are the 124 responses I expected. Vivaksha Zariwal. Okay, you have responded. Manisha responded. Yeah, I want. Yeah, you want me to repeat the second question? See, my two questions to you people are, the first question is, I got like a considering like what is a feasible percentage of a training and the percentage of testing data sets we should have for a machine learning or data science model? That is my first question. The second question is, I got my testing size as 0.1. What could be the training size? And Dr. Sonal have responded. Manju, what is the minimum set of training data is required? So it depends. Like you can have 100 or 200. It depends on your usage. Like it depends on like where is the source. Sandhya Rani have responded. Gatu Prasad have responded. Anil Kumar have responded. Anil Kumar Mishra have responded. Okay, that's it. Any other people? The rest of the people are not listening the session, I guess. They on the laptop and they are doing their personal work, I guess. Okay, so Sunita Panda have responded. Okay, enough. Like we don't have time. Not less than 200, maybe. Like see, like for Anil Kumar Mishra, see, thing is like not less than 200 we have given. It depends on your research. Only. Anyway, like the advisable, like some of the people have responded. The first person, Mr. Nand Kumar Mishra, training sets should be 80% and the remaining 20% is testing. That's awesome. So for the research, the expectation is more than 75%, or at least 75% for training. There is no clear rule, hard and fast rule. We don't have any hard and fast rule that this is how the training sets and this is how the testing sets are. Okay, there is no hard and fast rule. Okay, so the very simple thing is like above 75% is considered as a perfect training set, and 25% is a testing data sets. And for more accuracy, 80-20 is the answer. So over here, the people who have responded 80-20 are the correct answer. Okay, 90-10, yes. One person have given Abdul Ahad. I have given 90-10. Sir, you may ask me, sir, why can't I have 90-10, sir? Yes, you can have 90-10 also. Okay, 90-10 is also an advisable mode for medical, for satellite research, for rocket launching, yeah, high critical applications. In case of high critical applications, you will have this 90-10. You need lots and lots of training on the data sets, and you need, obviously, 80-20 is the best. Once again, I'm telling you, I'll go back once again from Mr. Abdul Ahad. From your point, I'm stepping behind, sir. The reason is like you need lot of testing also. How much you're training, that much you need to test the system, sir. So 80-20 or 75-25 is one of the best and feasible thing. And there is a person, Mr. Tulasidas, he had given my answer. And like 80-20 is also is my answer. And my second question is, I got my training set, so testing set as 0.1, man. Yo, I made a mistake. What is the testing size in that case? Please type it fast. It's already too late. Once I'm asking a question to you, this is my second question. I got my data testing data set as I made a mistake. I made a mistake. I made a mistake. I made a mistake. I made the testing size as 0.1. Sorry, testing size as 0.1. And what is the training size? Come on, guys, I'm waiting for you. Srinivas had given, Rajesh have given 10%, Srinivas has given 20. Let me repeat the question. Let me repeat the question. The question is, the test size is 0.1 I gave. 0.1 I gave. My question is, I made a mistake. Some of the people have responded properly. It's good. What could be the test size or train size? Test size is 0.1. Perfect. Thank you. Great. I'm really happy my session is good for you people. I'm really happy. Okay, because like most of the people responded correctly. So it's 0.9. 90% is correct. So most of the people have given the right answer. I should clap you. I should clap for you people. That's awesome, people. Awesome. So like over here, Mrs. M. Ishwari, madam, it's 0.9 because the sum of the value 0.1 plus 0.9 should be 1. Okay. Yes, because the scalar value should be summed up to one value. Okay, so x and y test size is 0.1. In turn, the train size is 0.9. Yes, people like before going ahead, like I'm reaching the end of my session. Before going ahead, I want to ask you people like how is the session? How is my sessions? Is it good? Can you unmute and give me a voice so that I'll be happy before leaving the program? Thank you. Thanks for the
Sir.
feedback.
Excellent,
Thank
sir.
you. Thank you.
Excellent, sir.
Really very interactive
Very
Thank
good,
you.
sir. Very nice.
and very knowledgeable, sir. The way you are presenting is awesome.
Yeah, thank you.
Good
Thank you.
morning, sir. Good morning, sir.
Yep, please.
Sir, your session is very excellent. I understand all the things, but I have a question. Sir, I am using desktop of Windows 7. So how can I run all these programs in my system? Which software I have to install? Am I audible, sir?
Yes.
Uh,
See, actually, like you need, I'm not sure like whether you have attended my first session. You need to install Anaconda.
and but sir, I have tried that one, but that is not installing in my machine in
Madam,
Windows
in that case,
7.
like you need to go out with the so you got Windows 7, right?
Yeah.
Windows 7 presents like you need to go ahead with your previous version of Anaconda. So you are trying to install the latest version of Anaconda, which is
Yeah.
like compatible with the Windows 10.
Yes.
And the Python version also, it won't work because we got the recent version of Python in latest Anaconda, and this won't work in your Windows 7. You need a you need to insert the previous in the same website. You just check
Yeah.
for the previous version of Anaconda and you just insert it, and it will work, man. And
Yes.
the problem, my personal advice, can you guys, like the rest of the people, can you please mute your voice so that it will be good for me. So this
Yes.
is like for Windows 10, madam. My personal advice, install Windows 10 in your laptop. The reason is like some of the functionalities, uh, the Python version itself, like a lot of changes is happening. The same code won't work in the previous version of Python. This is the recent version. So this code will work on September 2020 version of Python. Okay, so my personal advice, please upgrade it to work on this functionality. Okay, anyway, like
Yes.
I'm reaching the end of my session. So this is my
Yes.
training datasets. I got the inbuilt datasets here. So over here I got the training datasets, and this is my testing datasets. 90% for training and 10% for testing. The same here, 90% for training and 10% for testing. Yes. Yes. Like, see, this is the one I teach you, the scalar. What is the scalar, sir? It's not talking a lot of theoretical concept. I can tell you here, very simple. This is the value before scaling. And if you apply the scalar, the values are aligned. The values are aligned. That is where your scalar functionality will be. Yes. So here is the code I got. Your sklearn standard scalar, train test split functionality, you got the iris data sets, and you got the train test functionality, and and if you want to apply the scalar from the previous code, I put the same code here. You got this standard scalar functionality. So pre-processing standard scalar functionality added, the same code, and this code also the same. You got the algorithm, you got the data. Fit it and transform it if you want. Yes, I fit the data, I transform it, you got the training and testing data which is of standard value. This is how, this is the data which is used in your research, Yes, let's move on to the practical part. So this is your data on applying your like a scalar functionality. The same petal length, petal width, sepal length, sepal width, I made into a standard value. I don't want lots and lots of different values, man. Let's consolidate it into a group, a specific set of groups. That is where your system starts. Now this is the final thing. Like I'm going to finish my session now. Yes, I'm trying to like load the data set. So this is the basic code to load. So since I got the entire codes, everything is here, I copy and paste it here. Yes, copy paste, copy paste, copy paste. Let's finish the code. That's good. That's good. So like I got my iris data set. Where is my iris data set? Yes, copy it. I'm trying to copy this code. Yes, everything is copy and paste, man. Okay, now my iris data sets are splitted into, so this is how you are, that's it, the game is over. You got the data sets ready. So before closing my session, like I request to people, like please project your profile towards artificial intelligence. data science, machine learning, you will be getting a great future. And doing a PhD in machine learning or data science or artificial intelligence, you will be getting 100% assured job opportunities in Microsoft, Google, YouTube. Okay, the bigger companies like Netflix and lots of companies are recruiting people with a doctorate in this kind of areas like machine learning, data science, and deep learning and artificial intelligence also. Okay, anyway, let me explain the code once again and I'll finish the session for you people. Anyway, thanks for joining today, and I'm really happy I spread my knowledge to lots of people, and specifically I've accepted this session. The one reason is very simple. Instead of talking to your student, because the knowledge will stay with the student, but if I train the professor, the knowledge will spread to a lot of people. So that is my one intention. I've accepted this particular program. Anyway, thanks for watching this one. Yeah, this is the previous program we have seen. Yeah, creating a random data, and I've shown you how the data sets. This is a program. So creating a random data sets, and I've applied this functionality. The same functionality is applied on the inbuilt data sets. Okay, taking the Excel data, apply it, how it works. I've shown you. Now taking the inbuilt data sets, I'm showing you how we can apply. So this is how the segregation is. So I've got my x_train, x_testing data. So we got 150 data sets. Among that 0.3 0.3, there's just 30 rows is testing, and the remaining 120, I guess, yeah, 150 data sets, 120 data sets are for training. 120 for training. Oh, sorry, wrong. So 150 divided by 3, we have to specify like that, 0.7. So you have to segregate it. Calculator. 150 into 0.7. You got 105 data sets for training and the remaining 45 data sets for testing. Okay, so that is how the segregation is happening. And thanks for watching this program. The rest of the slides are a bit of advertisement, the people are not accepting, so I need to stop it now. Thanks for watching this program. Thank you.